Hey everybody, we're back into another lesson. We're going to start, since this is our 7-8 group, we're going to start today with a lesson for 9-7, which will be your lesson for May 13th, which is, I do believe, a Wednesday. So, and we'll also do a little bit of the closure. And then the closure will be finished on Friday with Mrs. Warzen. So I'll get it started and I'll do 3 of the problems, and then Mrs. Warzen will close it up. So that's where we're at right now for the 7-8s, and let's get it going. Let's not spend too much time. Now, I'm going to warn you right now, today's is kind of a little goofy as far as 9-7, because it's called the Pythagorean theorem proofs. Basically, you're proving or disproving, or trying to disprove, whether it works or not with right triangles. So I'm just going to show you some basics. I'm not going to get too deep into it because I don't want your head going on this whole thing. So again, this is just the basics, and then we're going to apply it. So let's get going. So if you notice here, this is what I look like after thinking about the Pythagorean theorem for 0.2 seconds and call it studying. Just put my face mask on and do my thing. Okay, first of all, we got to do the bad dad jokes as well. So what's red and shaped like a bucket? How about a blue bucket painted red? I know, you love it. Okay, we'll move on. Okay, so here we go. So we have our square, and I know it looks on yours probably a little bit rectangular, but it is a square, honest. And so if you remember from the textbook, we could use triangles, okay, to prove that the a squared plus b squared equals c squared. So I could move this thing right in there. Okay, so I'm going to keep this one out there. So if I move these in and put one there, let's see, we got to flip this one around. Stick that one in there. There we go. We can flip this one to here. And then I can grab this one and bring it here. Okay, you'll notice that, like I said, this is your B right here. This is your A, which makes this side C. So if I bring up my square here that fits in here, what we're saying is that if I do A squared and B squared, add those together, it'll give me C squared. And since this is C, that means this is C. So this area, which is C squared because it's C times C, if we take that area, set it aside, and then we take the area of these 4, and then we add it all together, that should give us this entire square. Okay, so we're using a right triangle, okay, with our a squared, b squared, and c squared. Now another way to also look at this is b right here. Well, we already know this is a, because it's right over here. So if we do a plus b, okay, we're adding those two together. And notice this is a plus b. So if we're taking those and squaring it, it'll give us this whole thing, which is at c squared again. So it's kind of like I wanted to say a vicious circle, but it's a square. So we'll call it a vicious square. It all kind of comes back and forth on what we're doing here. So by taking that, adding them together, after you square them, you will always get this, which is squared. Okay, so a squared plus b squared will equal this, which is c squared. This area, this area, this area, and this area, if we take those, okay, and I'll put that over here, and then we add it to the area of this thing here, that'll give us the area of the whole thing. So they all work in concert with each other. So let's apply this. So let's take the next step. Okay, so we have our lumberjack, Jack Miller here. He's 5 feet tall. Okay, and on a sunny day, his shadow was 16 feet long. So 16 feet here. And the tree shadow was 50 feet long for the tree. So they want us to find out how tall the tree is. Then we're going to find the length of the rope from here to there that he needs to attach to the top of the tree to stake it down so it does not blow over because we got heavy winds going on. So we're going to take it from the top of the tree to here, so then it stays steady. And it says that we should round it to the nearest tenth if we need to. Okay, so let's move this up a little bit, give ourselves some room to work here. Okay, the first part should be easy. Just finding out how tall this tree is goes back to ratios and proportions. So I know that since Jack is 5 feet tall and his shadow is 16 feet, and I know that the tree is X feet tall, but its shadow is 50 feet. I should be able to use that information and find out that tree. Most of us are going to do this. 16 times X is 16X. Okay? Then we will do this, which 50 times 5 is 250. And then you should know at this point to divide by 16. So X, which is the height of the tree, comes out to be somewhere right in the ballpark of about 15.6 feet. And again, that's an approximate. So that's about 15.6 feet here. Okay, now we can use that information to figure out this. So since we have this already, and we now have this here, we can now figure out this part. So give us some room here. So we have this, which is 50 feet squared. We're going to add it to our other leg, which is 15.6 squared. Okay, and that's got to equal this, which is c squared. So this is the point where you're going to pull out a calculator and you're going to do some calculations. Now, I did some on paper in front of me as well. So if we do 50 squared, we have 2,500. If we take 15.6 and multiply it by 15.6, you should come up with somewhere in the ballpark of, I do believe it was 243.36. And that should equal c squared. Let's add those two together. Okay, and so we put that in there, so we have 27, right? Yep. 2743.36 equals c squared. Okay, remember we got to get rid of this. How do you get rid of that? You should remember we take the square root, because these, okay, so it leaves me with c. And then I want the square root of that number. So I'm going to get back on my calculator, and I should get approximately 52.4 feet. So it's about 52.4 feet for this. Okay, again, a squared plus b squared equals c squared. In order to find the height, we just used a ratio and a proportion. Okay, let's jump to the next page. So again, like I said before, the Pythagorean theorem and that proof, just real quick, not a big deal. Make sure we know how to use it and that we're good with it. Now let's do the closure. Okay, so what I would like you to do is, this is 9-155 A and B. I want you to, whether you're in your textbook or you're just watching the video, you can copy these down now. I need you to find out what x is, and then find out what this x is. So you can pause it right now, go. Welcome back. Okay, so let's check your answers. So if we move this over, so you should have said, since I have 65, 80, and x, those three in a triangle have to equal 180. So if we add those two together, we get 145. Subtract the 145 from both sides, and you should have gotten x equals 35. Now let's do this one. This is the one I'm hoping you looked at this and you said, that represents, these two angles represent a half circle. So this plus this better equal 180 degrees. So we set it up 10x plus 2 plus 128 equals 180. Combine, okay, our like terms. We subtract out the 130 from both sides, divide by 10, and you should have gotten x equals 5 degrees. Okay, now, depending on who you talk to, you also might get that we take the 5 times 10 is 50 plus the 2, so the whole angle is 52 degrees. Okay, you're going to notice sometimes in your textbook they're going to have 5 degrees. Technically, it's not 5 degrees, it's 5 times the 10. So I'm okay if you left that as a 5 and not 5 degrees. That's okay. Because we're focused on the x, but if you went so far, you would have had the measure of that angle. Okay, and we don't know the angle name, but we can say the measure of that angle is equal to 52. All right, good. Let's move on to the next one. So we have 156A and B. So again, write them down, pause the video, do it on your own, and then come on back. So let's pause. Okay, now you're back. Okay, so let's check out this one. So we had 23 here for that angle. We had 58 there, and we had to figure out what this one was over here. I am hoping those of you that pay attention to vocabulary, this should have been super easy. So all you had to do is go, this angle and this angle, if we add them together, that will be the sum of the opposite outside angle. So all you had to do is add those two together to get 81 degrees. Some of you probably said, I'm going to take this and this, subtract it from 180, give me that angle, and then subtract that from 180 and do it. That's fine. This is the quick way. Now over here, you had 52 degrees, you had 128 degrees, and then we have a 5x plus 3. The key here is hopefully you notice that these two are interior angles. They're the same size, okay? So they're alternate interior angles. So this one better equal that one. So when we set it up, you were supposed to set it up as 5x plus 3 equals 128. Subtract 3 from both sides. Then divide by 5 to get x by itself. And x should equal 25. And again, same thing. The 25 there, it doesn't give us the whole angle, but some people will put it as 25 degrees. I'm good with it either way. Okay, and the last one, 157. Find me x here. This goes back to our Pythagorean theorem. A squared plus b squared equals c squared. You make sure you set it up right. Okay, so you can pause the video. And we're back. Okay, and this is where I find out, do you know what you're doing or not? Because these are the two legs, this is the hypotenuse. So you should have set it up as x squared plus 7 squared equals 15 squared. That should have been your setup. So x squared plus 7 squared equals 15 squared. 49 for 7 squared, 225 for 15 squared. Subtract the 49 from both sides. And then we're going to take the square root, okay? So we're going to take the square root of both sides, which gives me, and that should not be in here. They're going to ask you for it in a radical form and a decimal form. So here's what I want out of you, is you could have left this, once you did this, x equals the square root of 176, or you find the square root of 176. Okay, so I want you to ignore this. So you would have gotten approximately. Remember, it's approximate. I can't do that little goofy symbol, but you can. So you would have had x is approximately 13.27. Or that. So that's the decimal form and the radical form. So make sure you're reading your directions really well. So any more questions? No? We're good? Okay. Thanks, guys. We'll see you next time.